Welcome back. In this video, we'll start looking at the data lifecycle management pattern. This is one of the last of the patterns in the ETL patterns category for operational matters. So here, as the name suggests, the pattern deals with how do you deal with data through its lifecycle and managing the data as it actually goes through its lifecycle. What lifecycle for data really means is um, in the context of the OLAP platform, and the processing that happens along with it. You have various stages through which data goes through, starting from staging right of the raw source all the way through the functional views. Um, and at each stage, you're choosing to actually deal with copies of data. At various points, you actually make multiple copies of data in its raw form or in the form that is transformed. Then to service use cases like traceability, you need some of these copies to be live, but exactly how many, exactly at what point. So those all become critical questions to answer, because if you don't deal with that carefully, you might end up actually incurring a very, very heavy cost. Because we're talking about big data, we're talking about huge amounts of data coming through. So for every copy you make, you actually have a significant multiplier to the cost. So life cycle actually also refers to the fact that data ages over a period of time. So this refers to uh, the the um, common practice that data that's more recent is of more value. That's true for most use cases, like especially those which are business facing. For some use cases like data science, obviously historical data plays a very critical role. So it's not to say that the historical data is not helpful or useful, but the relative value of that historical data is different for different use cases. Whereas almost everybody will agree uniformly that the most recent data is actually the most useful. So there is a disparity in the value that's attached to these data that ages over a period of time. The third angle of life cycle that's also important to keep in mind is the variations in data require you to actually keep track of all those variations that happened over a period of time, and this becomes the way that you uh, reason about how the system evolved over a period of time, and also why you made certain changes. So again, traceability can be a question, a use case for something that happened quite some time ago, not just for the recent data. In which case, you still need to be able to answer that by looking at that version of data at that particular point in time, tracing it back. So that's also like a crucial facet of uh, life cycle and how you manage the data there. Okay, so in effect, all this comes down to the common notion that it is time based, right? So it's not actually based on stages of processing; it's actually based on time. That's the typical approach. Meaning, as an example, I want to store data for about 6 months, and after that, I want to archive it. So 6 months becomes the time. Or I want to get the versions of the source snapshotted after every day. So every day becomes the time element. The integrated warehouse that I'm building, integrated layer in the warehouse I'm building for business consumption, I want that to reflect the state of the business at the end of every day. Again, every day becomes a thing. For a real-time recommendation engine, I want to have the latest version of the data. I'm always up to date, and the model to be using that for recommendations. So that real time, which is basically the concept of latest, becomes like a very important factor. So invariably, it's time based, right? But then the really interesting question is what time is being referred to here, and here's where things get complicated. There are actually at least three notions of time in a typical OLAP, in a typical data processing journey. One is the notion of what's called as the event time. The event time is when that particular event actually happened in the business, in the source. So um, that's the first notion of time. The second notion of time is more functional in nature. So this is the notion of what does the business refer to as time. which could be different from what the event is, right? Which could be different from the source and the notion of time at the source. The third notion of time is operational time. Operational time meaning when did I execute a particular job? When did that transformation take place? So these three times are actually different. And based on what your question is, based on what your life cycle management uh, desire or requirement is, you would need to take into account which of these different times have to be considered for that. Let's take an example. I'm going to take this domain of e-commerce, and like with all the e-commerce platforms, what I most care about is the total revenue billed per day, meaning total payments received, total invoices raised, whatever, right? However you want to formulate the problem. But as a business user, I'm asking this question: give me all the revenue that I made in that day. I have with me the payment table, the same friend of ours from a couple of videos ago. Here, the payment table is exactly the same, and to calculate this answer of revenue billed per day, what I need to do is just take up the payment column, payment amount column rather, and then sum it up for the day. If I do a sum of the day, that's my answer. Sounds simple, right? Sounds easy. But then let's dig deeper, right? How do you actually practically answer this problem? And with automation, not humans, right? So revenue builds, like I said, is sum of payment amount. Straightforward. You can write SQL for this. You can write a data frame operation on that. Nothing fancy. Per day is also part of the requirement. So per day refers to I want to be able to get December 1st revenue, December 2nd revenue, December 3rd revenue. Yeah, sounds reasonable. Sounds doable. Yeah, all good. Cool. So then I start to map the data. To get to per day revenue build, I need to like determine which day a particular data record belongs to. Yeah. So that sounds again very straightforward to do. Take a look at the first record, December 1st, 10 o'clock in the morning. Yeah, it belongs to December 1 revenue. Take a look at the second record, 11:59. Oh, yeah, all is fair and square. It's still within the same day, logically. So belongs to December 1st. What do you do about this third record? This happened second early morning, 2:55. Yep. So logically, or rather, strictly speaking, you could say this belongs to December 2nd. But then there's actually a much more nuanced question that actually is thrown up here. That's this question of what does business consider as daily, as per day? Yeah, they consider December 1, December 2, December 3, fantastic, right? But in their definition of December 1 and December 2, December 3, is that matching with the definition that we've subconsciously chosen when we go with the payment time column that's captured in the source system? Source system says this third transaction happened the next day, early morning, to the 2:55 a.m. So the source system says that this happened in the next day. What does business think about this particular data? Is that belonging to December 1 or December 2? Wait, some of you might be wondering, how can it possibly belong to December 1? And that comes from this notion of what business considers as end of day. End of day, we all conventionally think about it as 11:59, 59, right? Or we think of it as the end of the working day when the shop closes for the day, which could be like 6 p.m. in the evening for a particular type of shop. What really matters for the business, though, is the notion of revenue accrual for a day. And that revenue accrual is an accounting practice. It's not about the store being open. It's not about logical time. It's not about calendar. It's not about the lunar calendar, solar calendar, whatever. It's actually about what accounting principles get used by the business. So let's take an example of a business where all accounting happens every morning at 8 a.m. Now, this is actually, quite common, right? If you see these small kirana shops, small shops that sell vegetables, they take stock of what all has happened the previous day, maybe the end of it, the first thing in the morning before the shop opens for the day. They make a ledger entry of every single transaction that happened, total it up, and say this is the money that I made yesterday, right? Why is that happening? Because the shop owner who is responsible for this could have actually left the shop earlier in the day, right? He could have left the shop at 6 p.m. or say 7 p.m. The shop remains open till 9. So he's delegated that operations of that shop to one of his deputies. So what he doesn't know is what's transacted after he's left the shop. To take stock of that, the first thing he does when he comes the next day morning is to look at the totals, all the rest of the accruals, total it up, and close the day and say, yesterday I did business of worth 1 lakh. So if you really look at it, what it amounts to is an accounting practice which closes yesterday's books as of that morning at 8 a.m. because that's when the guy comes in. Many businesses actually still operate in that manner, right? Accounting happens at a particular time. If it's software driven, sometimes it's 2 a.m., sometimes it's 5 a.m. It's very, very rarely exactly at 12 midnight. So there is a big difference, right, between what we assume as technical developers of data pipelines versus what business actually demands. So the other scenario could be accounts are closed by software automatically at 11:59, and then in which case the accounts could mandate, right, that there is no new transaction that gets entertained until 3 a.m. Then how do you deal with this third data? It happened at 2:55. So do I say that this transaction didn't happen? Did it happen and it got recorded for the wrong time? Did it happen actually on December 2nd, but then um, I mistakenly entered it as 2:55? How do you deal with it? It's not an easy question to answer, right? You have to talk to business, talk to source, understand the quality issues, etc. etc. Yeah, so in a nutshell, it's important to understand business closure, and that's how you know whether this third record belongs to December 1, December 2. It definitely does not belong to December 3, right? Because it's the first thing in the morning, the business closure will not be that early in the morning in practice. All right, so now I've gone ahead. I've mapped my record, the record number 3 to December 1, right? So notice that um, I've introduced the concept of business time. I've now introduced the concept of course, the event time is already there, the payment time. So now let's talk about the operational time. This process, which led me to get my revenue numbers per day, is actually an ETL job, right? It's a job that transforms the data, computes the sum, computes the aggregate, provides that functional view. So all of that ran at a particular time. So in this case, December 2nd, 8 a.m. So now I've got three times, right? There's the event time, which is what's there in the source. There's business time, which is what the business defines as end of day, etc. Right? And by the way, the end of day notion can actually apply even to end of time period notion, right? The time period could be 1 hour, 2 hours, 4 hours, it doesn't matter. It could be real time as well. So business time is like a logical time by itself. Operational time is the time at which I run the job, right? So that's December 2nd, 8 a.m. So if you then use all of this understanding to come back to this question, what do I need to do in order to manage life cycle of the data? You have to think about in what notion of time am I operating for a specific type of problem statement. So if I need to understand what was the business as on that day, the question that's really being asked is, for the nature of business closure that's happening, I want to know what was the state of the business. And this I don't want to know today. I don't want to know as of now. I want to know as of that particular day, sometime in the past. So then what you need to do for that kind of an activity to answer that question is to look at snapshotting the integrated data layer as of business time, not as of payment time, rather event time, not as of operational time, but as of business time. Which means if you take this previous example, December 1 snapshot becomes ready December 2nd, 8 a.m. in the morning. It's all available at midnight. Even though the business closed at a particular point in time, I am including all of the activity that happened after the midnight, up to the point that the ETL ran, up to the point the operational time clicked in. And after the operational time finishes, rather, after the operation finishes, the operational time window is like, let's say, 30 minutes for the job to run. That's when the business time, um, uh, rather, that's when the snapshot for that business time of December 1 is ready. So that's what is required for answering this question. What was the business as of a particular day? Instead, if my question is, when was the last time that I got good quality data from the source? Go back and answer it using these questions, notions, right? The business time does not matter there because it's a question about the source. Does the event time within the source matter? Not really, because that does not dictate how the extraction happens. It might, but it's not an explicit mapping, right? It's implicit. What matters most is that E of the ETL job, the extraction job that ran that morning to pick up the data from the source, to bring it into staging, to then do this job of calculating the December 1 revenue. That E that ran, that extraction that ran, is what determines the quality of the data. It's what determines how you go back and trace the quality of the data. Because it's with that E, the timestamp associated with that E, right, that allows you to go back to the source and say, look, there was something wrong in your source, there's something wrong in your table. Give me the version of that table as of 8 a.m. on December 2nd. Why 8 a.m. on December 2nd? Because that's the operational time of the extraction. So, quality checks in general, quality checks, failure handling, operational matters, reporting of what went wrong, data ops, all of that usually is operating on the operational time, not on business time, not on the event time. So, then what kind of questions uh, you have to think about event time in order to answer? Let's take an example here. What was the first item purchased after the discount launch? That's a very, very valid question that the e-commerce business user might ask. So here, there is the notion of day implicitly, but not explicitly, right? In fact, the explicit notion here is of sequencing. I had introduced discount schemes. I want to know what was the first item that was purchased after the discount scheme was introduced. So in essence, what am I doing? I'm taking that particular payments, basically the set of transactions that have happened. I'm ordering it based on time. What time am I ordering it based on? The payment time, transaction time, right? That payment time I'm ordering it. I look up the using my reference data, the time when the discount scheme was launched, which is again an event time corresponding to the discounts marketing program. I compare the two times and I see maybe the time when the discount was launched was at 1 p.m. on December 1st. So then the first transaction, the first item that was purchased after the discount was launched was the Samsung Galaxy. That was purchased at 11:59 because that's the event that happened after the 1 p.m. launch of the discount program. So to answer that question, I didn't need operational time. I didn't need business time. I actually just needed the event time from the source. Yeah. So in general, source specific functional computations end up being on event time. So the answers to these kinds of questions come from the event time. Now, the very, very important thing to notice is that the people asking these questions are always, in most cases, the same. It's the business. So it's the same business leaders who ask these questions because they're the ones who want to understand, how do I interpret this data? How do I make changes to my business? So they want to know what's happened. They want to know why it happened. They want to know what was the last issue that was resolved. They want to know what changed in the particular program, what changed with the source. So it's them who's asking these questions, but the context of those questions varies, and that's why when we build these functional views in the data warehouse in the OLAP system, we have to keep in mind what context somebody can actually be coming in with when they ask these questions, and then appropriately choose the data management principles that apply. All right, so with that, I'll take a pause. In the next and the last concluding part of this week's videos, we look at uh, differences between ETL and ELT.